Hey.
Answers in Atheism here.
Thank you. Why are you so lazy? Why didn't you set up a stream? Why didn't you set up a stream?
Because you did it. I said you do it, and you're like, okay,
well,
I'm
we
not lazy. I just like you can do it, and you're like,
we could have done it on like.
I'm reaching my monthly limit, so I was like, you can do it.
Oh, that's right.
Yeah.
I don't pay anymore, so I probably would. So what is the limit? What is the monthly limit?
You get to have a certain amount for free, and then
how much?
I don't know, whatever they say. It's 20 hours or whatever. I don't know. They just said that you're reaching them. I'm like, the month is almost over.
We can do that.
But I don't want to.
They want like
you'll get more
50...
views and people than I do. So we'll put it on your channel. You'll get all the attention. I don't want any attention anymore. I don't want any comments. I don't want people to watch my stuff anymore. That's the ticket. Anyways, please watch my stuff.
10 more views than you do. So
yeah. So, all right, we're gonna talk about the nature of reality. That's what we're gonna do. Okay.
How about
because I've got the logic. I've got the logic pinned down that there cannot be paradox. That has to be the core component of reality. There can't be paradox. And then after that, I'm not sure what logical laws have to exist. Maybe the law of identity, but when we're talking the Planck temperature of the universe, and maybe you know a little bit more about that than I do, physics is like wonky. So would A equal A still be true in the Planck temperature of the universe, or could we even know anything about that stuff?
What?
You're supposed to know all this stuff. Come on.
No, I don't know all this shit, man. I don't know all this stuff.
All right, chemistry is your thing, right? Right, yeah, not cosmology.
Well, yeah. Okay. Physics not so much, but
okay.
Space-time, that I understand, right?
Yeah. Okay. Yeah, but the Planck,
so go ahead, run that by us again.
Yeah, the Planck temperature, right? Where the Planck temperature.
Nope.
That's like the super mega hot temperature of the universe when it's like near T1 point or whatever. It's like the Planck. I don't know, because there's the Planck length is the smallest thing, and they call it the Planck temperature, but that's the hottest thing. I'm like, this guy, he needs to stop having things named after him, But he was really like cool, so they like naming stuff after him. Anyways, so in that state where everything is so hot, you can't even have atoms form. I think you can have neutrons and protons, but they can't come together.
Yeah.
So in that state, you can't really have physics there's barely physics to have physics with. So we can't really map anything. We can't do any mathematics. We can't really, and I'm like, okay, the laws of logic as we understand them now apply to our universe. And the law of identity, A equals A, that seems that, it's like, well, a proton would still be a proton. And if it did change to something else, then it wouldn't be a proton. So the law of identity seems like it would still be there. And I'm not sure about the excluded middle, maybe not, because it's either A or B. So maybe it transitions. So it's really hard to figure out, because if there's no physics, then you kind of have this giant question mark that you're um, trying to decide what that would be like. Just pure speculation. Um, but there's always a something there. Um, there's energy or heat, and I guess it's unclear what that heat is from. It's just because everything is super dense. But what is super dense? What is there to be
Right.
super dense? So, do we know what's there? Because if you didn't have atoms, or you didn't have, you know, even atoms, you just had the things that make atoms. And then even before those things, what is there in that we're talking about? That tiny dot that you always see in cosmology maps. You see the tiny dot that's the singularity. Do we
That'd be
know?
this one.
Yeah.
Yep.
Do we know what is in that? Do we know what that is? What is energy? I guess I don't even know if we can answer this, but what is energy? Uh, so that's a good
Well,
place to start.
yeah. The problem is that not only did space pop out of this stuff, right? Not only space, but time too. So
Yeah.
in here, there isn't. In here, if time and space are compressed down to this like singularity, right? That we don't understand beyond a certain point, so we don't know what the hell was there. I mean,
Yeah.
when time does not exist, you have eternity, but it's not the kind of eternity that stretches out like time, right? So it's a
Right,
different
because
kind of eternity.
there isn't really a before moment, because there is no
Right.
moments.
Yeah,
There's
there's no
just
north of the North Pole,
Yeah,
So
there's just is. It
right.
just always
Yeah.
is.
Right.
So that, if you wanted to label that God, as many people seem to want to do,
I don't know why.
I
Why
don't.
would they
Yeah,
do that?
well, because they want to believe in God, or they need, or they, well, maybe they don't want to believe, but they do believe, and it's like, okay, well, that's there's no room for a mind there, so this shifts then to more close to your field of chemistry and things of what makes a mind, and you've talked about this many times. It's an emergent property of the brain, but how much? Maybe we could talk about how much brain or how much matter do creatures need to form a mind, or do we know
Yeah,
that?
right. Yeah, that's another road we could go down here.
Yeah.
But anyway, the important part is this right here. We don't fucking know what the fuck this is back there, right?
Yeah, no,
We don't
it's
fucking know,
frustrating. It is frustrating,
Yeah. And I mean,
I want
it's
to.
so weird that we can't even talk about it, because you can't talk about eternity because it's not eternity. Like I said, eternity stretches out in our minds. We imagine
But
time stretches out.
what's
But
there?
before
What is there?
there is no
There is no there. There's no space. There's no
right.
time. There is no there. So is that nothing?
Yeah.
But it's
So
not
anyway, the
nothing.
important thing is we don't fucking know. Well, so what do we know, right? We know that we're out here somewhere, right? With the universe that's uh, so highly expanded with stars and with things and with atoms and all of that stuff. We know a hell of a lot about all of this stuff from the first few seconds on out, right? We know that
Right.
part, right?
Okay, so
I mean,
let's talk about atoms, because they're the smallest thing. So we've got protons and neutrons. What is that? What is a proton? What are those things?
right. Yeah, and that's where it gets weird, because in this thing here we have all these fields, basically that stretch out forever. And when two of these fields interact, we end up with like a particle, right? We call it a proton. But I mean, there isn't really the proton and the electron and the neutron and all the things in an atom aren't really like objects that we can think about. Okay. there's something else going on that we can't even wrap our minds around. This basically space particle or what is it? Particle wave. So it has this duality that we can't even think about, right? But the bottom line is
we always draw it like a sphere, but it's not.
Yeah.
That's not what it. But they did
No,
an image of
like
an atom or a molecule. There was an image taken of, I believe, hydrogen that they did that they showed.
Yeah,
and
it
so
looks fuzzy.
And it looked like round. Is that just what are we seeing there? I don't know if we can find that image offhand, but
yeah, I don't know exactly how they went about seeing a hydrogen atom. I'm not sure. Physics is not my thing exactly, but anyway, so what we do know is we know this macro level, right, where we all exist. We're here, right? and we are not a fucking neutrino, so we don't have to worry about quantum effects and all that stuff. And we're here, and we can deal with these little atom balls, and they pretty much describe really accurately what happens, right?
Yeah, but
so we have this,
we're made out of that stuff. So
we're made out of this stuff, right?
Why is it that my finger doesn't have to worry about passing through a desk, especially a capitalist one?
Okay, there was a really, really good video that came out about 2 weeks ago where he said this bullshit about atoms being full of space, that they're all space and no particle. He said that's not true at all. And he goes on for about 20 minutes to explain how that is not true. At that level, there isn't the kind of things that we like to imagine, little balls floating around real fast, going around real fast around the nucleus with a lot of space in between. It's not like that at all. It's this field kind of thing, right? So it's like this weird field, and you'll have, and atoms will have different shapes called orbitals, right? And have you ever seen the orbitals? You ever seen them?
I don't know. Yeah, I've never seen that. I don't know what that is. Yeah. Well, here's here's this photograph, quote unquote, of inside a hydrogen atom. That I put. Yeah. So yeah. And then this like how they did it. It's like, I don't know, whatever. I don't know. So I mean that looks like a ball to me, but I what do I know? I don't know what I'm looking at.
Let me see if I do some.
So that was the best I could.
Yeah, because that's an s orbital. Okay, that s orbital is spherical, but it gets a lot weirder than that. Let's see if I can. I wonder if I could show this.
And then you go, well, why are they even orbiting? There's like gravity that's affecting them, or at that scale, is gravity even a thing?
Yeah, they're not orbiting. They're not orbiting. There is, these fields have this shape, right? And you can see in this diagram that they. Let me see if I can make me bigger. Okay, you can see that they have, like, when you add electrons and you add protons, and of course you have to add some neutrons to stabilize things, you'll end up with all these different orbitals, like p orbitals and d orbitals, and they get really strange. And there's this wonderful thing that looks like a dumbbell, but that would be like, that is the how did he explain it? That's basically the shape of how the thing is going to interact with something else. It's not necessarily, you couldn't necessarily get a big microscope and go look at that, right?
Yeah.
So they don't
I guess I want to know what that is. Like that little dot they point at, the little, what is it? Fluctuate. What is it called? Oh, nucleus. Okay, that's the nucleus, right? Yep. What is that? That's just energy. But what is energy? Like, what are we talking about? It's too abstract.
you can't know because we have nothing in our macro world that we can think about that is going to explain it to us. The only way you can know about this stuff is with the mathematics, right? So we have to get over this idea that we're going to understand this shit, right? We're not.
Yeah. But I
But
mean, so we don't do. So do is it that we don't know what it is, or we can't label it precisely because it's so abstract? It's like a number. It's like the
it's
number
the
one or
same
something.
problem we have with consciousness. We don't
Mm,
have a proper intuition for it, right?
mm.
There's no proper intuition that we can figure this stuff out with, and that is our problem. And so we have to accept a little bit of epistemic humility in how we understand these things. And what the Christians will do is they'll say, well, how did something come from nothing? Because they're imagining that at the beginning there was this extremely tiny dot that eventually disappeared into nothing, and none of that shit makes any sense. So
Yeah,
we
because
have
it's
to
always
quit.
it's always been something. We don't really. I mean, even when we're
Right.
talking about an atom, which is already so small that it's incomprehensible to in a way, we already don't know what the nucleus is. Like we could say it's energy or a fluctuation, and it's like, yeah, but what is that?
Right.
Right, electrostatic forces. It's like, what are these forces? Where did they come from? And
Yeah.
all this is
What is?
language that doesn't really apply at this level. So we get out now. We're looking at hydrogen. We're looking at now we're looking at molecules. We've kind of gotten away from atoms. We're bigger than atoms now. These are
Right.
atoms grouping around other atoms in a certain configuration that makes oxygen, or different atoms that configure in a different way to make what we call hydrogen. So these things moving around doing this dance, if you will, are producing these molecules that we call elements.
Yep.
And that's a little bit more familiar to me because oxygen and hydrogen. Uh, I've seen water, but I've never seen a water molecule.
Nope.
Uh, how many water molecules? Well, because the eyes are, I guess I would say with a microscope or something like how many would we need before we could see it? Let's say with just a
Oh,
standard microscope, or do we know that number? I don't know if we know that number,
yeah.
but
We do know
I,
that
I would
number,
think
but
millions or billions or something. I
I
would
don't know that
guess.
number.
Yeah, I would just speculate it would be a big number.
Oh, let's see. Well, you mean with our naked eye or with a microscope?
With a
Hmm.
microscope, I think with our
Oh,
naked eye
shit.
it would be trillions and upon
Well,
trillions
with a
of these things.
microscope or with an electron microscope, I think there are some techniques in microscopy where we can actually see proteins, and we've seen roughly the
Mm,
shapes of proteins. So the light kind of bounces on. So there's something there. There are objects there, and if we get any finer than that and say, well, what are they made of? It's like that's the shit that we intuitively can't handle. So we just have to accept there's an object there and it occupies space and time, right? So that's the
yeah,
important part.
it's
The
like I
important
guess
part
that's why
is that,
they call it strings. Like it's vibrating, it's moving, it's doing this beautiful dance, and
yeah.
it's yeah.
So
Once we
we
get the
know that,
molecules, then we get the bigger stuff.
right, and we know that that an object is at some location in space and time. And I don't know what space and time is made out of or any of that stuff, but we can model it with these balls, right? And we can say, oh, so this thing is like uh, 100 nanometers away from this thing, right? And it's like a lot further away from something else from a distant star, right? It's 4 light years. Uh, so I mean, we know that things extend in space and time. The thing is that we are this size thing, right? We are at this level here, right?
Yeah,
this is our
huge.
scale.
Yeah, we're huge. I mean,
it's our scale. So you have to think about scale. And with that scale, we've been able to model these atoms right down to atoms to where we get down to those orbitals. And with quantum mechanics and the math, we've been able to calculate these orbitals and actually make sense out of chemistry, right? And we can make sense out of what happens if you pour vinegar on baking soda, right? Or if you, subject sodium to a bunch of chlorine gas, or burn sodium and chlorine gas, you'll end up with some salt and a whole lot of it. You'll also end up with no house, I think.
Yeah, well, so whatever it's made out of, we can't really exactly say, but once we get to the beyond that, we're at a molecule, even beyond that, we're at something that we would recognize like a grain of salt. And we're like, okay, that's more human, because it's like I can understand, I can hold a grain of salt, I can put it on my tongue. Now, that's an interesting thing. I can put sugar or salt on my tongue and I instantly know what it is. Right. So there's a whole thing going on there that we can know about all that, right? So the apologist, theist, philosopher loves to go back to when we don't know a lot of stuff and goes, well, how did it all start? Where did it all come from? Where did all these elements come from? And it's like the elements were just there chilling out in the ocean or whatever they were doing. Why did they come together, or how did they come together? And I'm like, I don't know. They just did. They felt like it. They could. Carbon, as you taught me, carbon loves to grab hold of other elements because it's like a little whore of elements, right?
Yeah. Well, yeah.
It just loves
it only wants 4 of them. It doesn't.
Yeah, only wants 4 of them. Doesn't want any. Yeah, it can only handle 4.
Not greedy.
I mean, is that as big as it gets as 4, or is there more than that? Is there?
Let's go take a look here. Okay, so right there. This is a periodic table of elements, right? So, and it's arranged in a certain order. So, on over on the left here, hydrogen it likes to bond with one other thing. Okay, so it'll only grab one thing, and lithium and sodium and potassium and rubidium are all one thing. Okay, these things like 2 things. Calcium and magnesium like to grab 2 things. Then we go over here, and don't ask why this shit works this way. It has to do with how the orbitals build. But over here we have boron, which isn't very popular, but carbon right there. Okay, so boron is 3. It likes to grab 3 things, and carbon likes to grab 4 things. But then when we get to nitrogen, we start going the other way again, because the shells basically, it's closer to a full shell. So you think it would want to grab 5 things, but actually it grabs 3 things, right?
Yeah, no,
so it bonds to 3.
Now you say oxygen? Shell. You say shell. What do you mean by shell? Is this another abstraction?
Well, that's the Bohr model of it was kind of the old model before quantum mechanics hit, that there are these orbitals, and in the first orbital there are 2 electrons, and then it just builds one shell over another shell.
Oh, okay, yeah.
That sort of thing. Okay, oxygen likes 2 things, and fluorine likes 1 thing, and neon doesn't like anything at all. It's fucking stuck up. It's an inert gas, right? But the neat thing is, like right here is where life happens, with carbon wanting to grab 4 things, and then we have phosphorus and sulfur and chlorine, and then over here we have some metals that all kind of gather together and create what life is, right?
So 4 is the biggest so far, then, or as far as grabbing things?
No, there are. Chemistry is complicated. Okay. but for the most part, we can think of it that way. But anyway, I want to let's take a look at this, right? So okay, so we got a carbon atom right here, right? So this is a carbon atom, okay, and it likes to, and I don't know why it keeps doing that, but it keeps doing it. It likes to grab 4 things, okay.
Yeah, it's horny.
So you have a carbon atom, and if you put a hydrogen here, hydrogen likes to grab one thing, right?
Yeah.
Okay, we have hydrogen.
Well, it's already isn't it already grabbing the carbon back, or is it wanting to grab? It's being grabbed by the carbon.
Yeah,
it's still free to grab something else.
Yeah, it's consensual sex. They're grabbing each other. They're grabbing each other, basically. Okay, so we have a hydrogen here, and we have a hydrogen here, and we have a hydrogen here. Okay, so everybody's happy. So we got carbon, which wants 4 things, and we have hydrogen, which wants 1 thing. Now, oxygen wants 2 things up here. So we can look at water, basically, and we have hydrogen. Okay, and that's water. Okay, but this one right here is called methane. So that's methane gas, right? Okay.
Yeah. What are we waiting for?
That's where it gets cool. And the other thing, let's see, we can get rid of this right here, and we can put an oxygen right there. Okay. And then and of course, oxygen wants 2 things, so it's going to want a hydrogen, right? And so this is wood alcohol. This is methanol. Okay. So that's wood alcohol. So we can do that. Now, carbon has a really unique property because it's right in the middle. It's, it's 4, and then it starts counting down. It counts up to 4, and it counts down to 4. So one of the things carbon can do is grab, let's see, I'm not sure if I use the right color. It can grab another carbon right there.
Yeah.
Okay. And then that is going to grab more hydrogens, right, to fill out its valence, basically, to fill out its shells. And so right here we have ethane, okay? And if we, I don't know if I,
yeah,
I don't know if I have to keep
you a new
thing.
microphone.
Really? Is it bad?
Yeah. Yeah,
Why?
you entered a helicopter for a while there. I don't know what happened.
What the fuck was it? Okay, let me check settings. And how's it now?
It's fine. It was just you were entering a helicopter for a while.
Yeah, it must have been something with the connection. So
okay, there's no shells. It's convenience, right?
Yeah,
right.
let me know if that. Let me know if that happens again. Okay, and so we can add another carbon out here, right, and fill it with hydrogens, and this is propane gas. So we have methane with 1 carbon, ethane, and then propane. Okay. And if you, let's see, if we change this to an oxygen and that to a hydrogen, we have isopropyl alcohol. But let's not do that. Let's go the other way. Oh shit! I gotta get the right tool here. Okay, I want a hydrogen there, and I want to get rid of. This. You remember I showed you wood alcohol with an oxygen and a hydrogen? Okay, so now we can do an oxygen and a hydrogen here, and that's the shit that gets you drunk. That's ethanol. So it goes from ethane. If you oxidize ethane by adding an oxygen atom in between that hydrogen, you'll end up with alcohol. Okay. If you go up here, and we can do it this way. The other thing that carbon can do is it can have double bonds. So it can grab an oxygen all by itself with a double bond. So now it's got 2 things, right? So it's grabbing with 2 hands, right? And this here is vinegar or acetic acid. So what happens when you put your wine in a vat and you leave it there too long, it'll turn to vinegar. So it goes from alcohol and it oxidizes.
So if you got rid of one of those bonds, does it change completely?
Yes.
It
would be ionized, and there would be a there'd be a negative charge here. So there'd be a negative charge right there. And that's why it's an acid, because that hydrogen floats off occasionally. It floats off like it's its own proton, and that makes an acid. And then this will have a negative charge, and this will have a positive charge. Okay, that's why it's an acid, because that hydrogen can float. But we don't want to go too far down that, dude. What I want to show you is this. What I'm trying to get to here is let's come on. What the fuck? Why can't I get a big? Yeah, there we go. I want a big one, right?
Yeah, I was gonna say, like, we could do like vinegar and baking soda you mentioned. So can we map out those two things and then
we could, but I don't want to.
Yeah. Oh, okay, fine. Is it too big? Is there too many things in them?
Oh fuck! Carbonate. I'd have to look up baking soda because I don't remember. But anyway, okay, so carbon can bond to another carbon, can bond to another carbon, can bond to another carbon. When we do this, we end up with gasoline. Okay, if you have 8 of these, now we're going to leave the hydrogens out from now on, right? We're just going to pretend they're there because they always fill out with hydrogen, right?
Yeah, I remember you said that.
Okay.
They love hydrogen for whatever reason.
Right. But this one here with 4 is called butane, which you have in your butane lighters, right? And if we were to add an alcohol or OH to it, it'd be butanol, which is, and if we were to add an OH to it and a double bonded oxygen, we'd end up with butyric acid, which is rancid butter. Okay, so these things are all connected, right? But if you keep going out here and you add like 8 of these things, you'll end up with octane, which is, I think that makes your engine knock like crazy. I think octane makes it knock. I can't remember. So they have this octane rating. You have your octane rating on gas, 92 or whatever when you fill it up. But anyway, you keep going out, and these long carbon chains are called alkanes, and they are what petroleum is made out of. Basically, if you get out to about 50, you end up with petroleum jelly or Vaseline, right? Keeps adding carbon. But the other neat thing about carbon is it can go this way and add another carbon down here and add another carbon. And
now,
that
why
it
would
can
that
add 2 carbons.
Why would that be any different than it going one way, that it's going a different way? Why should that matter?
Okay. A straight chain, it's going to be like a really long, lumpy molecule, right? Okay.
Right.
And if oh god, now I'm going to forget my basic chemistry, unfortunately. But then when you get branch chains, okay, it's going to change the nature. It's going to change the melting point. It's going to change the point at which it boils. It's going to become stickier, right? Because these molecules all stick to each other to some degree.
Yeah.
So it kind of depends.
And I'm looking at really an abstraction. These things are floating around each other in these weird spatial way that you know what I'm saying? Like we're not. This is just like an easy way for us to look at it. But
right.
That's not what it looks like. Like it doesn't.
No.
Like we can't. Yeah, it's all just mathematics that's mapped out in a way that we can understand. It's like
right.
Yeah, it's so weird. We were also kind of talking a little bit of consciousness. I know you love to talk about this, and I guess we're not there yet. We're still too small to get to any proteins yet, I'm guessing.
Right. Okay. Before we leave that, okay, this is what carbon dioxide looks like right here, right? Okay. I mean, they're kind of glommed together, kind of looks like, because when you really got down and started looking at those things, light ain't going to work anymore, so you can't really define looking at them, right? But I'm trying to find some 3D pictures of molecules, and it's kind of hard to find. Yeah, this over here. That depicts. I think that's is that acetylene? No, acetylene has 3 bonds. There's 3 carbons. I'm not sure what the fuck. Oh, carbon suboxide, I guess. It tells me right on the thing. But anyway, so yeah, we're depicting it, in a way that we can understand. So when I show you this diagram, it's a way that we can understand it, right? But anyway, the point is that carbon, the complexity with which you can bond different things to carbon is fucking enormous, right? And you end up with all of these different possibilities. Okay, we could have a nitrogen and 2 hydrogens, and now we got an amine, and this is a carboxylic acid. I mean, the complexity with which carbon can combine is why we exist. Okay, that's how life happens. So enough of that.
All right, so we finally got to life. Man, it took a lot of things.
Right.
Yeah.
Right. Yeah, what the fuck is it? So it's
yeah, what is life? We can't even seem to define what life is properly.
Right.
That's a problem too, but that's a natural language problem. But you would think science is good at defining things, and go, what's the basic definition of life? Something that consumes, grows, changes, dies?
There are some weird chemical complexes that could do that. There are some chemical complexes that can reproduce, So the problem is when you get down below the level of the cell, okay, and you start thinking, can't be bothered with chat while he is creating art. Okay.
Yeah, that's right.
So
look, I'm glancing over at chat for you.
Yeah,
I'm asking. If somebody, look, everybody that's listening, I'm asking Mike questions that are insanely complicated and expecting him to know the answers without any prep work. It's really unfair.
Why does he not? Okay, Thomas, is he live? I am live. I'm sorry. Let's see. Where did you ask me something? Shubham Chobi? Shubham Chobi?
I didn't see him ask anything.
Okay, bro. I have never been to Saturn. I can't find a question. I randomly stumbled into this channel. I don't want to ignore it. Oh, you randomly stumbled into my channel.
I don't see any question from him.
Yeah, I'm not paying attention to chat, guys, because this guy is stretching my mind, getting me to go back to fucking basic chemistry.
Come on, man. I'm trying to unravel the true nature of reality here.
Yeah, tricky to define life. We make lists of properties. Yeah, it's
exactly.
There are many books on trying to define life, and the thing is that when you try to define it, you're going to try to go back to the very most basic thing that could be life. And it's a gradient. You're not going to find a point where life is here. Life happens at this point, or life happens at that point. You're not going to find it.
Well, I heard somebody love these sort of sayings that are just so, brain dead sayings of life comes from life. And I was like, wait a minute. Is the sperm and the egg, are they alive?
Yeah, they
so
are.
They are alive. Yeah. They're living cells, but they don't have minds.
No, they don't have minds.
They're just there. So they're operating. Is it instinct that they're operating on? What are they operating on?
Well, that's the other thing. They do kind of have minds, because mind is the same way. You go back and you try to find the simplest thing that you could call a mind, and there is no point on that line where you can say, oh, mind starts here. Okay. It goes all the way back. Little sperm cells, they know where they're going. They have a purpose. They have little tails. They wiggle. They swim. They're heading somewhere, right? They have a purpose. They're just like other guys in that they're fighting it out to get at the girl, the egg, right?
The egg just sits there and wait for them. Yeah, the egg just chilling there waiting for them. Like, come on, guys, come on this way. Why doesn't the egg move to go get the sperm?
I know. Never does. Women just
come on.
Women
Why do I gotta do all the work?
Women do not give a shit about us at all. Yeah, even at the very most basic level, they don't.
But the egg
You know?
isn't the woman, and the sperm's not the man. I mean,
Kind of. Kind of what we're stuck with.
Yeah.
Anyway, okay. So what the hell is life? So we know that we like life today basically has to have a cell. So we start with a cell, okay, and from that cell, that would be the egg, right, and then the little sperm guy, little wiggly thing, heads up there and impregnates the egg, and it becomes a single-celled zygote. So it's a zygote, right? That's where you started out as one cell, and it had to come from a cell.
Now, wouldn't it be Zy human? Because I wasn't a goat, so shouldn't it be called
No, at that level, we're all goats.
Okay, fine.
Just
all right.
Just like humans are still apes, yeah, we're still goats.
All right.
So basically, you start out as that one thing, but the other thing about life, which is kind of fucked up, is that this zygote by itself would just die. It would dry up and die. Nothing would happen. You have to have a mommy, right? So you got to have an environment around that. So it's in a womb, or it's in an eggshell, or it's in some sort of an environment, right, from the very beginning.
Yeah,
so
something
life makes
provides
life.
Nutrients and because it needs to eat. Why does it need to eat? Why does it need to consume stuff that isn't it to stay alive?
Let me think. It would just dry up. It would eventually break down and just kind of crumble up, and entropy would take over. So entropy is why.
Entropy.
Yeah,
right.
you have to add energy to the system.
It's a constant fight against entropy. Basically,
all of life
is a fight against entropy. Because as we get old, we're constantly fighting entropy, but we're losing. We're always losing the battle.
Yeah. Let's see.
So shouldn't it be that when I eat enough that I could surpass entropy completely? I absorbed enough energy.
Yeah. See, yeah. I tried to do that. I went to Sam's Club and I bought a whole case of Rice Krispie bars.
Didn't help.
I ate them all. Ate them all.
But I mean, if you eat enough, I guess you'll be big enough to become a star, and then Rock's race. Yeah, sure, whatever. I don't care.
Okay.
Yeah.
So anyway, so I'm trying not to ignore. I'm trying not to ignore.
Yeah, ignore chat. I'll see if there's anything interesting over there.
Okay. Anyway.
So we've got the zygote. We've got zygote. Okay, so we come from that. We need stuff. We need to eat stuff to battle off entropy. And if we lose that fight, we die. So once we're dead, that's it. We can't keep doing anything interesting. It's only when we're doing the fight that we're doing something interesting with it. And I guess the same, we go back to the molecules. Unless they're doing these orbits, they're not those molecules anymore. And then they're not doing anything interesting. So the whole universe is really just an uphill battle against entropy, but entropy is going to win. So it's like, well, why did it bother? What was it thinking? It didn't. It just did it. It just did it because it could. And I guess that's why people want to insist that there's a mind behind it that made it start, when we don't need to posit that, because a mind is so complex that it could never be the explanation for something like that. Because our mind, I always try, and I always go back to like, well, I would make it different. I would do it different. I wouldn't do it this way. I wouldn't have, why have this convoluted system? Why have this convoluted cell? Why have these little protons? Why have any of this? Just make it real simple, keep it simple, stupid, it's just the little building blocks, okay. Much simpler than this. It wouldn't have to be so convoluted, right?
Look at that shit. I mean, that's just ridiculous.
There's so many things going on, and that's just kind of an abstraction too of that's art. That's not really what it looks like.
Right. What they really look like is very interesting.
Just a little blob of thing.
I think I have a picture of that. I do. This is actually this
abstraction is the word of the day, by the way.
actually this is what a brain looks like. Actually.
Oh.
Yeah. So I mean the I think we got a neuron right here and a neuron right here, and this is how packed the goddamn brain is. So I'm pretty sure
Why
that
is
is
it all the different colors?
they colored it differently so that it wouldn't be fucking boring. It would really be fucking boring if they showed you what real color it was. But anyway, things are very, very complex in life, and this is a eukaryotic cell. This is a very complicated one, a lot more complicated bacteria. But the thing is, I don't know if I could talk about this or not. When we look, you want to look back at the very beginnings before the cell, right? You want to go back all the way back to the very first simplest cells, right? Was a lipid membrane.
I mean, I guess what I'm trying to get to what is anything at some level, and it seems like we go too far one way and we can't really we get into this like abstract world of symbols and numbers and mathematics and I'm like, at that level, I'm not even sure that informal logic can serve me any well. It's like I've got the law of identity, I've got the law of non-contradiction, maybe, and I've got the law of exclusion, maybe, and I've got the law of no paradox, maybe, and I'm not even sure about these things at this point. That's too abstract. I can't go there, but I can go down to the cellular level. I can go there and I can understand that to some level. But I guess it's like, okay, we have these molecules floating around of carbon and whatever, and they start to form proteins because they do. There isn't like is there a driving force that made them do that? I guess some people like to posit that, lightning hit them, something, they're just bumping into each other until this happened, basically, as best as I can get. And then once they had that initial protein, there's something different about a protein that allows it to do stuff. And what is it about a protein that makes it different than any other molecule? Protein can do stuff, can build stuff, but the other stuff can't do that. It's just the way that's just the way it is,
Things polymerize. Okay, the carbon polymerizes. You saw the chain I did, right, when I made octane.
Right. Okay, what's polymerization? Because that makes me think of Yu-Gi-Oh.
Polymerization means a whole bunch of things stuck together. Okay, there are polymers and there are oligomers, which are just a few things stuck together. They're small polymers, right? And then polymers, were used to plastic and stuff like that. Well, these proteins, amino acids, they polymerize, and that's how they form proteins, basically. Amino acids do, right? And it turns out that we've got 20 wonderful little proteins here. And let me see if I can get this on the screen. Okay, some are non-polar. That means they don't like water. They prefer not to be around water. And some are polar down on the bottom. Maybe I can make this smaller so I can see the whole goddamn thing all at once. But each of these things has its own unique little, its own unique properties. And this whole group of unique properties ended up, goddamn, answers in atheism is in the way. How do I shut that off real quick? What the fuck?
You'd have to edit your name to be nothing.
What?
Or
no, there's a way to shut it off. Hotkeys, recording, layout. General? Is it in general? Not show. Orientation, shift videos up automatically. Shift. Oh, fuck me.
Just scoot it up. It's fine. I don't need to see those polar things anyways. Screw them.
Anyway, well, okay. So we got 20 proteins right here. Some have some are bases, right? They have a plus charge. They're basic, like alkaline, and other things are acidic. Down here, there's two of them, and they have a minus charge. And then we have just polar things that aren't particularly grabby. They aren't particularly negative or positive, but they have a charge, and they will glom on the water, basically, the polar ones, right? And the non-polar ones will stay away from water. Well, then we create these massive chains of proteins, and depending on how you combine them, you will end up with all sorts of different weird shapes with little pockets in them and stuff like that. And that's where life really gets going, because the complexity, just like when I was trying to tell you that carbon, you can make it really complex by hooking it up in all these different ways.
Yeah,
These things too hook up.
So
in
now
many
we're at really big chains of really big stuff, and then they can hook up in new ways,
Yep.
and do more stuff than before. So it's just like it's more and more complex as we go on. And
Yes.
see, that also screams undesigned, because design would be simple. It wouldn't be this complicated. This is too convoluted.
I got to show you a picture of that. Let's see, where the hell do I have that?
The one guy asked, even though I know we're switching between chemistry and physics here all the time, but apart from the charges, what's the basic difference between a proton and neutron? I don't think that there is any. That is the difference. One is pro and the other is new. One is positive, the other is negative.
You see this? This is a diagram. This is a diagram of this is how proteins interact in order to make a cell divide. Okay, that's one thing.
Hell.
That's what God.
That's a lot of things. Wait. Put back that. I want to see that. That's get back there. Don't you put that off the screen yet? I wasn't done with it.
Trying to find my cursor.
Trying to
find my cursor. You're making me crazy.
I know. That's my job.
Yeah, so a whole bunch of shit has to happen, basically, in order for a cell to divide.
Yeah. This is just these are just the proteins interacting with each other to tell a cell to divide.
Right. Yep. Here's the chromatin organization, toposomes. Let's see, but there's another one here, which is this is P13K signaling. Or no, I'll show you. Okay, check this out. This is why we fucking die. This is insulin. Basically, that's the insulin network in the cell. Okay, the insulin receptors right here up on top, that little wrench-looking thing, and it goes down and it connects to that one and that one and that one, and they go down. And if you see a little cross like that where it goes across, okay, where the C-amp is, that means it inhibits a protein, and if it has an arrow, that means it excites it expresses a protein or activates a protein, right? So it goes through all of these chains, and then eventually it gets down in the fucking nucleus over here, and then it goes down and it affects how DNA transcribes, and then some proteins get made and they get sent out here, and then they go through a whole bunch of shit where the RNA or messenger RNA gets transferred into a protein, and then it gets folded, and then it comes up and it does something else. And it's just a mess, okay? And this is what happens when evolution cobbles life together. This right here is enough to tell you that it was not designed. But a Christian will look at this and say, oh, no, this is enough to tell you that it was designed. Because, my God, if it wasn't designed, how would all this work, right? Well, how it should work.
Well, barely works. That's the thing, is it doesn't, now with CRISPR, I've heard about CRISPR every now and then, where they can take the DNA and there's this thing in the DNA that doesn't copy itself right. And all they have to do is fix that. And then not only would we stop aging, and we would I don't know if we would age backwards per se, but we wouldn't have to age anymore, because DNA would be copying itself perfectly. So we can break biology, and that's amazing.
Yeah, but eventually, what would happen? Well, humans could probably pull that off.
Yeah.
But if DNA did not mutate when the environment changed, basically the population would die. So
Oh,
it's
yeah,
a
that's
variation. Yeah. Now we're branching off into evolution. So I don't know if we
right,
want to go
right.
there yet. But
Well,
anyway,
okay,
the
yeah,
point
because
is,
yeah, if we made it so that our DNA copied itself perfectly, you and I could live indefinitely, hypothetically. Um,
right.
but we would encounter other issues of a changing environment that we would then not we'd have to adapt the environment to suit us
Yeah.
so we could keep living. Right.
Yeah. And
Okay.
if we didn't die, eventually there'd just be all one thing, right? Like if there had been a prokaryote that was so successful that it can survive in any environment, anything the earth threw at it, and it was the very best one, then all there would be in the world is that one particular kind of bacteria, nothing
And
else.
not
That would
now
be it. Pretty boring.
can we get something that would survive in outer space with what we have, or we'd have to tinker with it, but can we
Yeah.
could we tinker with what we have to live in outer space as humans, or well, we wouldn't be human, we'd be something else. I don't know what we would be, but you know what I'm
Yeah.
trying to ask here, like
Yeah.
because we're
Well,
eventually yeah.
what we got to do is AI. We are going to become digital intelligences, and we have to. This diagram here shows you what has to happen in your brain.
Okay, I
This
want that. I want you to send me that. That's great. I need this in my email.
if you I have to buy it in order to get
Oh,
it's real bad resolution, and I
oh,
think they want like $150 for the goddamn. I
what?
really want it for Christmas, but
Where is it?
I'm I'm not sure where I found this.
Oh,
Just found it probably not useful charts, but it would be there's some chart you can buy online. Basically, it shows you all the operations in the brain. So anyway, let's see. So we got the insulin pathway. Oh, here's another one. Here's the P13K pathway, signaling pathway. This is a signaling pathway that just makes cells grow and does a whole bunch of other stuff. It kills cells. It's used in about 10 different places, right? This P13K
oh my
signaling.
God.
And this is the shit that you have to learn when you learn molecular biology. But you can see all these connections. So it goes from a cell receptor. So something is communicating from the environment into the cell, and it goes down and it just does all of these different
See,
pathways, and they all connect
I,
and you get down
I
molecular.
think that's why we love the question why. Look at all the things that look like the letter Y there.
Oh yeah. Yeah, there's a
you
lot of
know,
why.
you know what I'm saying?
There's a
But
lot of
no,
why.
those two tubes go in, and it looks like the letter Y is shoved into the wall there. You know what I'm saying? That
Yep.
blue thing, the green thing. That's why we
Yeah.
keep going Y's. Is we're full of Y's.
But there's so much more that we can talk about here. There's so much more to this shit.
Now, okay, so consciousness or the brain, or okay, we said that there's this gradient of what it is to be alive. There's a gradient of consciousness, maybe, because like the sperm has some consciousness in a way, doesn't it? I mean, it's moving, it's trying to get to something. So is that conscious? We don't even have a good definition of consciousness.
Yeah, the thing is that you can go all the way back. Like I say, you can go all the way back to a worm, to a insect, to a single cell, and consciousness is going to be on a gradient, right? And so you got at the very bottom here, we got a cell, right? Okay, so here's a cell, and it has receptors on its surface, so it can kind of sense its environment, right? And it say it has we'll give it a flagellum, right? So it can move, right? And over here we have something where it detects sugar. So there's some glucose over here, right? And it detects sugar. And if we were to measure the sugar in the water, it would be a graph. And it keeps switching to the fucking thing. It would be a graph. And the glucose would become more and more concentrated until we got to the source here, right, where the glucose was coming out. Anyway, so what the cell does is it knows that on this end of it, basically the opposite end from this, is glucose. And so it flops its little flagellum and it moves over and it goes to glucose. That is the most fundamental part of consciousness that there is, right? A cell moving. It's also the fundamental morality. It's moving toward what is good. It's moving away from what is bad. If we light a fire over here, big fire, it's going to move away from that, right? It's going to go the other way. So it goes toward good things and away from bad things. And if you want to define life, it would be, that's called valence, a binary. It's either plus or minus. So it has a valence, I call it. And it moves towards something good or away from something bad. At the very basic, that defines life for me, basically. And from that, we can build all the way up to multicellular organisms. And of course, it gets more complicated.
Yeah, I was gonna show you this website. It is kind of laggy though. That is the problem. The openworm.org, and there's a it's like they built a worm. I'm not sure what they did. It's so complicated, I can't understand it. It's like you can see a worm, you can see all the things in the worm, and it's like, okay, cool. And they built it. Like they built it with computer models, not like it's not like they took what was in a worm and they put it. So it's a virtual worm, and it's like, okay, that's cool, you know. And I'm sure that you. Maybe, you might have to do it. Yeah. You have to explore the worm, enter the worm. I love it. But it was kind of slow for me. It was because, and now that we've shared it, I'm sure that we'll get it hammered by all the other atheists trying to play with the worm.
Let's see.
But I bookmarked it because I thought it was just so interesting that they built this virtual worm that has all the components of a real worm, but in a virtual realm. And so there's different sliders you can have, and you can look inside of it, and you can rotate it with your mouse and such. And it probably works better when we're not streaming because we're using internet to,
right.
But at any rate, yeah, it's going to lag too hard right now to do much of anything. You kind of have to play with it just by itself, I think. But I met the guy that's okay. I think it's C. elegans that they're working on. I met the guy at the University of Minnesota, and he knew everything there is to know about the neurons in the C. elegans worm. And he's one of the guys that probably had something to do with this. So let's see. I don't remember where I heard about this from, but as soon as I did, I was like, I got to bookmark that and look at that every now and then and try to understand what the hell I'm looking at.
I'm trying to go back here. I'll have to play with this.
I'll have to play with it offline when you're not doing anything but that, I think. And then you can probably screen record it or whatever. And, but I knew you would, I'm sure other people will like it too, because it's just, it is a worm, but it's built from digital stuff, but it acts like a worm would. So we're using the computer power, which is just a bunch of zeros and ones. Again, this is all abstract. It's just turning on and off stuff, but you can take that and make it mimic life, and then you go, well, what have we made here? Have we made life? Well, if it's behaving like life, then it's alive.
Yeah,
you get to a point where there's no. Now, I was playing with ChatGPT as I like to do, and I was asking about consciousness, and I said, look, I turned off. They put me under for colonoscopy, right? And so
they put you under.
They put me on.
What the fuck?
Yeah, you didn't get under. Well, see, because they don't like you. They like me.
Well, they give me a ton of fentanyl, and I have a good time. So yeah, okay.
Yeah. Well, anyways, I was awake, I was there, and I was like, oh, that's a weird sensation. I felt my brain get all fuzzy, and then I was like, then the nurse was like, okay, wake up, and I'm like, what? And so there was no me between the.
Yeah.
And I said to Chat GPT, I was like, okay, so I wasn't dead, but if I had stayed not me there long enough, then I would be dead. So what makes me from the moment that I'm not me to the moment that I am me? And it's like, well, you continue, and and it's like it couldn't, it broke. I killed it. I hurt GPT's feelings.
And every night when you go to sleep, you die.
Yeah,
Basically,
exactly.
You go into a deep sleep and you're dead. That is what death is like, right? And I have a friend who's in real bad shape, and we were talking, and I made the comment to him that death is really cool because it is the most don't give a fuck that you will ever have, right? You just don't give a fuck when you're dead, which is really kind of cool when you think about it, because when you're dead, you won't care that you're dead.
But I don't like that idea because I'm used to existing. I don't know what it is.
Death is only a problem when you're still alive. It's not a problem after you're dead, right?
Yeah, I know, but so I said.
So I mean, don't dwell on it. It won't be a problem after you're dead.
I'm donating my brain to science. That way, they can preserve my brain, because it doesn't.
Yeah.
It seems like even if we reconstructed the brain from the ground up, the same a copy of your brain exactly, it's not you,
right?
But it is you. But it isn't, because there's this. It's like, okay, so what is that? What is it that this you? Where is that in the brain? And it isn't there. It's like an illusion or something,
right?
And I'm like, well, that then the copy is me. So if the brain was off for a long enough time, but we fixed it, and that's still me. But if you copy the brain, then that isn't me, because the continuation of self from one moment to the next, but there's interruptions. And that's what I'm saying, is that interruption. Right. So if from now, this moment in time, I freeze my brain, and then a million years from now, they unfreeze my brain, that's still me.
Yep.
But if my brain disappears and they reconstruct the brain, maybe even from the same components, the same molecules that made my brain,
right?
Why isn't that me?
Well, it could. What if they made two of you? What if they split or made three of you, and then woke all three of you up at the same time in the same room with the same pants on? Well, you can't share
awareness with that. The law of identity says no to that. So, yeah.
Well, yeah, you would immediately start to differentiate into three different yous. So what that tells you is that at every moment that the you from 1 minute ago is dead, and you are a new you right now. The closest you're ever going to come to what you are, to what am I, is right here, right now. You are what you are right here, right now. And there's always this right here, right now. If you think about it, you're going to miss the mark. This cogitating inside of our heads, this little hamster running around the wheel thinking, we miss most of life because we're busy thinking, right? The you is right here, right now, feeling all the stuff around you, feeling and hearing my voice coming through your speakers or whatever. And it's really an interesting thing to dwell on. But you're never going to grab it, right? What if we could freeze you right here, right now, with the thought that you have right now in this microsecond, and keep you that way for 100 years? You would not be alive at all. You wouldn't experience anything. In order to experience, you have to be moving constantly through life. You have to have this lived life thing. You have to just keep going. So,
yeah, but there, in essence, then when I was under, then I wasn't dead because there was still stuff going on. So it is again that endless fight against entropy is really what life and
Yeah.
existing is. Um, in a
You're never
secular,
really, yeah.
yeah,
You're never alive. So you're never alive, so you can't really be dead.
yeah, there you go. Oh, that made it all better. Oh my god,
Oh
that's
yeah,
more confusing.
yeah, yeah. It's it's like I used to tell my twins when they were little kids and they'd be upset about something. I'd say it's only life; it'll be over soon.
Yeah, I
It
like
made
how
them
we
feel a
all.
lot better, right?
Yeah, play with your
I was a
worm
good,
offline. It's always good to play with it in private. Exactly. Yes. Um.
yeah.
So, Mike, what I've gotten from all this is we can't explain bleeping hardly anything, but we can explain some things. We can
Yeah,
explain a lot of things, but we get to these weird points where language breaks down. We're stuck with these abstractions. We're stuck with
right.
saying things that aren't really true. We're stuck with like half truths, which means everything is illogical then.
Well, not really.
Ah!
I think everything's pretty cool.
Yeah. But it's like we need more words, maybe. I don't know, but yeah.
Well, all of this, like the thing about consciousness is, it is the hard problem of intuition. So it's all
Mm,
about coming up with an intuition for what's going on around you, and
yeah,
that is a creative process. So you're
yeah.
creating constantly, right?
There's a couple things like, okay, you feel, or I feel like tingles in my arms and like hair raising, like talking about this stuff, like every now and then I'm like, ooh, like tingly sensation. What's that? So what's going on there? What is that? Do I need to go to a doctor? Is that normal? Like,
Right,
why?
right. Yeah, fuck.
It's like
Wait till you're as old as I am.
my brain is bursting out chemicals of pleasure because it's like, ooh, this is new information. This is exciting. Um, and then I had this thing where I woke up and my whole brain felt like it flashed. It was like, vroom, like there was this sound of, vroom, and I'm like, what the fuck was that? It's true. And I asked Chat GPT, and it's like, this is like a brain, whatever the hell it's called, and it happens. It's normal. I'm like, is it a seizure? Like, nah, probably not. I'm like, probably not. What is it? What happened? Why did this happen? What is going on? Like every now and again, it will happen. I'm like, well, I don't like this because, like, I wake up, I'm like, and I'm like, it's like it felt like my brain exploded, but your brain can't
Yeah.
explode, can it? Can your brain explode? I guess your brain could. Oh,
Well, an
okay.
aneurysm. Yeah, you can always have
Yeah.
an aneurysm. Yeah.
No, I don't want that. Yeah, why does that happen? Stop. Why?
That's the good news. Okay. Okay. Contribute today to Open Worm. I think you can contribute money.
Yeah.
So anyway, Shoban Chobi is asking me. So get started, explore the worm. So let's see. Contribute today. What are we contributing? Okay.
Your
Why?
money, I guess.
Oh, it's
So
an
that
open source project.
Yeah.
Okay.
If Nerdy wrote it, might be able to look at the code and make a video about it or something, because now he's gonna make a video. I'm gonna watch his video. He's gonna say words. I'm gonna be like, that's nice. He said words. I don't understand half those words. The other half, I think I understand. I'm gonna leave some stupid comment about like, hey Nerdy, can you like make an anime of me? And he'll ignore me. And then I'll complain about it. And we'll just keep going in that cycle endlessly because we like doing it to each other. I guess. I don't know if he likes it. I like doing it. I don't know that he does. I love Nerdy. He made a song for me once. Yeah, it's so.
Okay, so I
you.
haven't been on GitHub for a long time. So I'm okay. The core bundle.
Yeah.
So
Yeah,
here's a
see,
client.
nerdy understands all this stuff. It's beyond
Data
me. I'm
sources.
dumb. If there's not a link to click to download everything and install it for me, I'm helpless. I was just go, there's things. What do I click? There's too many things. Yeah, no,
So okay,
grind me. Thank you.
we got some.
I'm guessing
got
that
some
was directed at
YAML.
me, Chubby or Shobi. How do I say that name? Shubin. Oh, there's no way I'm pronouncing that name right.
Oh fuck! It's written in Java. Java's
Yeah.
despair. That's bad. Please.
Nerdy understands it. I'm sure he does. He knows all the things. He understands.
Okay, data sources. So the fuck. It's been a long time since
Not really a mind. Yeah, I know. It's labels. Okay, everything is labels. Everything is an abstraction. Everything is a thing that we can't. It's sort of like things, but it's not. Great. And I try to apply logic to it, and at some level, logic breaks down. Until it doesn't. There's always a thing that has to be like no paradox allowed. That's for sure. And after that, I don't know. Yeah, there you go. See all that? That's code. There's
it's written in
code.
Java.
Yeah, those are words.
Okay.
Good luck with that.
Well, I used to get paid to write this crap, which I fucking hate. Yep.
Nerdy hates Java. He wants Python. Everything in Python. Yeah.
Yes, Python. Python or Ruby, nerdy. Ruby. Please go back to Ruby. Ruby gets shit on, but Python is also wonderful because Python has so many plugins.
Well, you'll have to. Java, maybe Nerdy can make the Python worm.
I'm so sorry that they wrote this in Java because if you really want to fuck your life up, Java is despair. Ruby is heaven. Ruby is heaven. So anyway,
all right.
Well, we figured that out.
Yeah, well, I don't know that we answered anything, but it was fun. And I think I learned some stuff. I'm not sure anymore, but you know what? Thank you for this because I love nomming your mind and it probably would be better if I just like, here's a bunch of things that I want to talk about. I think I sent you like an email ages ago with like just all sorts of random things that I've written. And I'm like, here, do stuff with this. And you're like, oh my God, I don't know what to do with all that. I'm like, good luck, laws. And I never heard back about any of that again. And I'm guessing you just were like, yep, put that in a folder and bury it. I don't know what to do with this. I don't want to touch this. I don't know what you want from me.
Yeah.
Good times, man. Good times.
I'm trying to find the fucking good. I had another thing that
paradox is not just a label. No, I refuse. No, paradox is not allowed. No such thing as paradox. Pinocchio says, "My nose will now grow. His nose grows." There you go. No, it's not in my head. It's real. It's real.
I cannot find. I cannot find where I was.
Daddy. No, Daddy Thomas. No, zombie. No. All you zombies.
All in your head.
Yeah. No. Zombie. All right.
So I totally fucking lost my the thing I was going to show you.
It's all right.
Which is. Yeah, I know.
Yeah,
it was something I wanted to get. There's something I wanted to get into next time. I'm working in embryology, right?
Oh,
and there's a really neat thing about embryology that all you kids really ought to get excited about. Now, in gaming, you have these soft body engines, right? These physics engines. Like when you throw a ball, it bounces and comes back and hits things and moves around. Okay, and that is what we need in embryology. And I started sketching out what we would need in order to represent, like I want to write a Ruby program or maybe Python to represent cells in an embryo and how they divide and differentiate and turn into organs. But anyway, so there are soft body physics engines, and I'm looking for a really good one that would help with that endeavor. Anyway. That's a whole nother fucking subject.
Do you know of the Thought Emporium YouTube channel? This is another one that I'm sure that you'll love.
What is it called?
The Thought
Thought?
Emporium.
No
Yeah.
shit.
Okay.
Sounds good. Exciting.
It is. He's he does stuff that's really like insanely amazing. He took a photo with a potato chip. He turned shrimp into fabric. Gatorade
Okay.
he's
Nice.
trying to grow living rat neurons to play Doom.
Wow.
Just normal stuff. He made a leaf made out of meat. He's just doing normal things that
A leaf made out of meat?
Yeah.
What
Yeah.
the fuck? Okay.
Yeah, it's great. It's good
That's
times,
awesome.
man.
Okay.
I love it. I watch this stuff and I'm going, that's cool. Yeah. Here,
Well,
put it. There it is. It's down there. There it is. There.
yeah, I just subbed to it.
Yeah,
So
but it's there. It's there. So put it there. Let me show the thing. I want to show the thumbnail. Give that thing. Put it on the thing. Click that thing.
put what?
That
Put
thing.
what where?
The thing.
The thing?
The
thing.
Down there. There it is. There's the thing. See, making a meat leaf.
A meat leaf. Oh,
Yeah,
I like
sure.
a meat leaf. Oh, wow. That would change salads for me entirely.
Yeah.
Make them out of meat.
Yeah, exactly. Why not? So I don't
Cool.
know. Yeah.
Anyway, boy, you really like to run. You really like to run me across a whole lot of different topics.
It's look. That's how my brain works, and that's why I make random videos randomly, and I don't have a schedule.
I don't think saying that's how it works is accurate.
No, I will say it how I want to say it. You.
That's how it operates, but I wouldn't exactly call that working.
All right. Yeah. Anyway. All right. Okay, thank you for this.
Okay, guys.
Bye, everybody. Don't forget to sub and like and comment on my videos.
So where is Captive Desk? Captive Desk, did you put a link to Snatta for tonight? In the chat so that everybody can see us over there in about 2 hours.
They know that it's going on.
1.5 hours I have to go and recover my fucking brain. Thank you. Yeah, you evil bastard.
What do you mean by brain? What is brain?
Yeah, what do you mean by brain?
What do you mean by what do you mean?
Yeah.
What is anything anymore? I don't know.
Goodbye,
right,
cruel
everybody.
world.
Bye.
Goodbye. We're leaving.
Hit the button. Hit the button.
Hitting the